Nothing. Don't worry about it.
We're going to talk about lesson 13 here.
I'm a very, very good cook.
Lesson 13 is a review of our inverse trig functions, trig equations, more trig review. Okay? So, inverse trig functions. Okay, start off review. Sine of 30 degrees is what? 1/2, right? That's one that you're supposed to know from the chart to be able to find pretty easily, right? So, how can we find sine x equals 1/2? You know it's 30, right? Because we're asking sine of what angle equals 1/2. But how do we actually, how could the calculator help us? Because right here, technically, if I go to my calculator and I punch in sine of 30 degrees, as long as I'm in degree mode, it's going to tell me 0.5, right? How can I do this on calculator? Yeah, the inverse. Because here, this says sine x equals 1/2. In order to flip-flop the x in 1/2, we can use the inverse function. And so if I do sine inverse of 1/2 equals x, I flip-flopped my 1/2 and x, and that would give me 30 degrees. Now, if I'm in the radian setting, it's going to give me some funky decimal, right?
Should it be like 0.5, 2, 3, 5, 9, 8, 7, 7?
I don't know. What's pi divided by 6? Do pi divided by 6, and I'll tell you. Pi divided by 6, 0.52359877756. Because what it's doing, guys, when it's in radians, and here, if you're in the radian mode and you do sine inverse of 1/2, it's going to give you the radian answer, which is pi over 6. But the calculator's not going to spit out pi over 6 at you. It's going to give you the decimal equivalency. Now, if you go into degree mode on your calculator and you do sine inverse of 1/2, it's going to say 30 because it's in degree mode. So as much as I say be in radian mode in here, there are occasions when degree mode could help you go back and forth, right? Okay. So notice what it said. How can we find sine x equals 1/2? By using the inverse sine functions. Okay, I'm trying to think. Were all of these used in pre-cal? These are all ways to represent inverse sine functions. Sine inverse is in sine to the -1 power, and it's when that -1 power is directly after sine before the number of variable. Arc sine. Did the pre-cal book use arc sine? I'm trying to remember. Okay, so calc uses it a lot. Okay, so don't, remember arc sine is the same as sine to the -1. Inverse sine, I don't feel like we see that one a lot, but sine to the -1, arc sine, be familiar with those. Okay, we talked last year about the graphs of the 3 inverse trig functions. We talked a little bit about these. And this first one is sine inverse. Okay, with sine inverse, the domain goes from -1 to +1, because on a regular sine graph, the range goes from -1 to +1, right? So now the domain goes from -1 to +1 on sine inverse. The range goes from -pi/2 to +pi/2. And that's just restrictions on where sine inverse exists. So you'll notice our answers for sine inverse must lie between -pi/2 and +pi/2. Do you remember what this correlates with? Remember those 3 half circles? Remember these? These 3 half circles are on the next page of your notes. These are your range values for each function. So this is on sine inverse, what your answer could possibly be, on cosine inverse, and on tangent inverse. So sine inverse, remember, your answer is in quadrants 1 or 4, and it's expressed between -pi/2 and +pi/2. Even though in our brains this is 3pi/2, for sine inverse you have to call it -pi/2. Does that ring a bell? Okay, even though this is technically 11pi/6, if we look at a traditional unit circle, it's -pi/6 in sine inverse. Okay, While we're here, cosine inverse is 0 to pi. Nothing fancy there. Tangent inverse is negative pi over 2 to positive pi over 2, except it does not exist at those specific endpoints. Okay? So be familiar with those half circles. You learned them last year. For me, they're just a good visual because I can visualize them in my head. Okay. These graphs you'll want to be familiar with because you will be expected to draw these graphs on a test at some point, probably. Okay?
On some point, probably.
At some point. I usually make sure it gets on there so that way we're knowing them. But so sine inverse, negative 1, negative pi over 2, up to 1 pi over 2. Tangent inverse. Okay, guys, think about tangent is normally kind of like a cubic going up, isn't it? So the inverse is it going sideways. The normal, my mind just totally blanked here. Okay, our domain here is negative, well, no, our domain here is negative infinity to positive infinity because that's going off, right, to either end. That's our typical tangent range. The inverse is, or the range is negative pi over 2 to positive pi over 2, similar to sine, right? Except that these are asymptotes, so we don't actually include those. Cosine inverse, that domain again is negative 1 to positive 1. My range, though, is 0 to pi. Okay? So be familiar with those, please. And remember, I'm going to just put C graphs on next page because these do correlate with the graphs on the next page. Okay. Example 1. Evaluate. I'm going to encourage you to think without your calculator. Sine inverse of square root of 2 over 2. Since it says sine inverse of square root of 2 over 2, what are they asking me?
It's saying what? So the sine of what equals the square root of 2?
Exactly. Sine of what angle equals square root of 2 over 2? Is that one we know can remember from the chart?
45, right?
Yep. So you can say 45 degrees, or you could say pi over 4. Okay. Now, if you put it in your calculator, sine inverse of square root of 2 over 2 is, I guess, spit one of those answers back at you. It is. Okay. And this was an easy one. It's positive, so we automatically know quadrant 1, right? No need to think hard about it. Okay, example 2. Evaluate cosine inverse of negative square root of 3 over 2. I would start with the basics of what do you know about cosine and square root of 3 over 2. Where does cosine equal square root of 3 over 2? Pi over 6. Okay, so whether you call it pi over 6 or 30 degrees, I don't care. Now, I drew it without asking. This is cosine inverse, right? Cosine inverse, possible answers happen in quadrant 1 and 2, yes? This is asking for the cosine inverse of negative square root of 3 over 2. So do I want the quadrant 1 answer or the quadrant 2 answer? I want the quadrant 2 answer because this is all students. So cosine is going to be negative over here. How do I find that answer? How do I find that answer?
You could do 180 minus 30.
Okay.
Like 150 would be degree angle, right?
Okay, so right here, 30-degree reference angle in quadrant 1. So what is the equivalent to the 30-degree reference angle in quadrant 2? And so we can think 150 degrees, right? What is 150 degrees in radians? Or, this was pi over 6 up. What is a pi over 6 before pi? 5 pi over 6. Okay, so you can say the answers of 150 degrees or 5 pi over 6. With sine and tangent, if we came up with pi over 6, we could just say negative pi over 6. Because their negative quadrant is just the equivalent, but negative. Cosine is the one type of problem we can't do that on. Okay? Sound familiar? Because more than anything, that's what we're trying to make sure this all sounds familiar. Okay. Next set. Solving trig equations. Just like finding inverse trig functions, only now we will be given different intervals to stay between. So we must use our unit circle to think this through. And so the first example is solve secant x equals negative 2 on the interval from 0 to 360. Which means I want any answers that are going to make this true. Could be 1 answer, 2 answers, 3 answers, 4 answers. Depending on which quadrants this is true in. So, secant equals negative 2. Thoughts?
We do like inverse secant of that thing. Especially about
Well, because if the secant of x equals negative 2, that means that the cosine of x is equal to 1 over negative 2.
Inverse secant is a thing. But if we just go strictly to inverse, we might lose answers. If that makes sense. I'll come back to that thought here in a moment, okay? But it is a thing. I'm trying to think, did Ross say something?
I said, since secant x is equal to negative 2, that means the cosine of x would be equal to 1 over negative 2, right?
What's the relationship between cosine and secant? They are the reciprocal of each other, right? So normally we would say, okay, secant is 1 over cosine equals negative 2. But to just speed up the process, you can go straight to, okay, if secant is negative 2, then cosine is negative 1 over 2, the reciprocal. So we're basically trying to figure out, when does cosine equal negative 1/2? Now, you can use the inverse function to get yourself started, but this isn't specifically saying inverse. So that means all 4 quadrants are available to pull answers from, is what I'm saying here. As opposed to, if we do inverse, we only have 2 quadrants to pull answers from. Hi, Lily.
Also, out of all days, I waited till the day of my test to forget my calculator at home.
Oh, good. It's not written. Good news is I have a cafe you can borrow.
Thank you.
You're welcome. There you go, my dear. Okay, guys. I'm going to draw the quadrants, right? Couple of things to start with. First of all, what's our basic angle we need to start with? Forget the negative for a moment. Cosine and 1/2. What do you know about cosine and 1/2? Pi over 3? So in other words, saying, I'll just put over here as a side note, cosine of pi over 3 equals 1/2. Or in other words, You could say 60 degrees, couldn't you? And, you know, I don't really care how you process through this, whether you process through in radians or degrees. It's more about how your answers end up appearing and knowing, you know, how to get either of them there. Okay, so now we're going to be looking. The angle in question then is 60 degrees or pi over 3, yes? Actually, this particular problem, we want to answer in degrees, yes? Because it says secant x equals -2 on the interval 0 to 360. I want degree answers. Where are we going to find these answers?
So there's going to be one in each quadrant.
Okay.
Right, because it's allowed for full interval.
Well, there's officially one in each quadrant, but what do you notice here? This is when does cosine of x equal negative. So are we actually going to pull one from each quadrant?
No, we're going to pull one from two quadrants.
Yeah, we're going to have two answers here, aren't we? All students take calculus. So which quadrants do we have answers in?
Yeah.
Second and third, because all is positive and cosine is positive. So we are looking for the 60-degree angle up here and the 60-degree angle down here. How do I find those two?
Subtract. Okay, so since 60 within the first quadrant is 60, so we get that one, you can subtract 180.
Okay. So we can do 180 minus 60, and that's going to be 120 degrees. What else?
Could you do the same thing with 270 because it's approaching 271? That not work?
It wouldn't be 270 minus 60.
Or you just take 180 plus 60.
There you go. That's the easiest because based on the fact that this is 180, 60 before it, you subtract 60, 60 after it, 180 plus 60 is going to be 240. Now, if you wanted to go off of the 270 mark, realize if it's 60 from the x-axis, then it's 30 from the y-axis. Okay, and this is where you just have to be familiar with the unit circle, right? Look and decide how is it best to get there. So my solutions are 120 degrees and 240 degrees. Questions on that? Have you made enough notes to help you remember? If so, I'm ready to go to example 4 on the back. Don't worry, we're going to get some more practice on the back here. Okay, solve sine squared x equals 1 on the interval from 0 to 2 pi. So again, all 4 quadrants are eligible, right? One answer per quadrant depending on the situation. How do we solve sine squared x equals 1? And I don't know if this helps or not, but if I rewrite that as sine x raised to the power of 2, that's still sine squared x equals 1. Yeah, since it's sine squared x, we can take the square root. If you take the square root of one side, we're going to take the square root of the other side. What's the square root of sine squared x? Sine x. What's the square root of 1? See, I just have to start looking around and making eye contact, and someone's going to say, crud, what is it she wants? Okay. So when you take the square root in an equation setting, we always have to account for the positive and negative roots, right? Say that every time. I'm going to keep saying it. So we really have two different situations here, right? When does sine x equal 1? And when does sine x equal negative 1? Okay, do you remember anything about this?
So since it's positive and negative, it can be both, right? So are we going to have four answers? It'll be on the axis, right?
Okay. Always four possible answers. Just depends on what's happening here. Yes, we are thinking on the axis. Okay, these are quadrantal angles. Now, what's the order in an ordered pair? Cosine, sine. And so, just for review, what would the ordered pair here be represented as? Right 1, up or down 0, yes? Up on the 90 degree, we call it 0, 1. Over at 180, it is negative 1, 0. And down at 270, 0, negative 1. And again, this is all this pre-cal review, right? All this trig review we've got to remember. Based on that, now do you see where your answers are? Sine is 1 up here. Sine is negative 1 down here. Because it's the quadrantals, we only ended up with 2 answers instead of 4. Now, how did you state your answers, Jacob?
I said 90, negative 90, but negative 90 is also 70.
Okay, so 90, negative 90, 90 to 70, or because it says radians up here, I'm going to give my answers, sine equaled 1 at pi over 2, and it equaled negative 1 at 3 pi over 2. Okay? As a, not saying that Jacob's answers were incorrect, just what's equivalent, right? Okay, quadrantals coming back to you. Okay, moving on. Example 5. Tangent squared x equals 3 on the interval 0 to 360. What do we start off doing? Square rooting. Square root of tangent squared x equals 3 is going to be tangent x equals plus or minus square root of 3. So officially I'm solving two equations. I want to know when does tangent x equal positive square root of 3 and when does tangent x equal negative square root of 3. Okay, so that's one of the questions we have to figure out is what is our base angle here. And square root of 3 is at the bottom of the chart. So it is at 60 degrees, and we're working in degrees, aren't we? Which means one possible answer for tangent of x equals square root of 3 is 60. As we keep practicing, I'm drawing my graph right now. So there was 60 degrees, right? Okay, what's the rest of your thought process here?
So since it's plus or minus square root of 3, we just find the 60 angle.
Pretty much. Because it's plus or minus, you're going to have both positive quadrants, both negative quadrants. We're going to have 4 answers. Now, I already found one of my positive, right? And then where's my other positive, though? My other positive is technically down here in tangent quadrant, right? And so at that point, we are going what? 60 degrees down there? So what is my other, when tangent equals positive square root of 3, what's that answer? 240. because you have to do 180 plus 60, right? Now for my negative quadrants, obviously my negative quadrants are going to be the other ones. And I'm breaking them up just because, okay, what if this is just one of them? Could you handle which ones are which? Okay, so negative square root of 3 happens up in the sign. What is this one when you go 60 up? 120. It's 180 minus 60. What about quadrant 4? Because you would be finishing at 360, right? 360 minus 60 is 300.
You want me to do it here, or should I take it? Study hall. It's your choice.
Who do you have for study hall?
I just got done the resource room. That's all.
You're in the resource room?
Yeah, that's just where I kind of hang out.
That's fine. If you want to go ahead, who's in the resource room with you?
Right now, Miss Joe.
Okay, yeah. If you want to go ahead and just tell Miss Joe you're doing a test for me.
Yeah.
You wanna go ahead
Well,
and
she
do it?
already knows.
Okay.
So
Yep.
we're
Go
gonna do
ahead.
this,
That's
and
fine. You might as well go ahead and do it in the resource room then.
Yeah.
That'll make it easier on you. That way you don't have to go down there later.
Yeah.
Thanks, Kogan. Okay. You guys got those 4 answers? So I appear to have lots of kids with 4-hour study halls this year. I'm not sure, I don't remember this ever happening this much, but we're going to have lots of test makeups, I guess. Okay. Did you guys happen to try and look at the next one?
No, do we need to use the one like anything?
I'm not going to go that ugly. Okay, we have cosine squared x.
Cosine x, I'm like,
Well, we have a cosine squared x plus 2 sine x minus 2 equals 0. Now, that's doubling identity as if it said sine of 2x. This is 2 times sine of x. So there's a big difference there. 2 times sine of x is much nicer. Okay? It's just a regular sine x multiplied by 2. So like saying 2x. Now, the deal is, okay, we're solving these equations, right? We're using our basic solving skills. The problem, I have cosine and sine in the same problem. This is like working with an equation with x's and y's both in it. I don't want to solve an equation with x's and y's in it.
so are we going to set, like, one of them we're going to decide as a y, the other one's the x, then we're going to set, like, so for instance, we could do like cosine one like that, like cosine of that is equal to the other part of it.
Nah. Because it is just one variable. It is just x. They are just x's here.
I like half of
Cosine squared x can also be sine squared x minus 1, or 1 minus sine squared.
The key is we can't work with sine and cosine, right? What's Ethan using to convert that cosine squared over to sine squared? You hear that Pythagorean identity in there? He didn't say that's what it was, but hopefully as soon as he started talking about it, it sounded familiar to you. So, okay, so side note here, I'm going to write down that sine squared theta plus cosine squared theta equals 1, right? That's just your reminder of how this magic is going to happen. So, cosine squared, I think Ethan eventually said it right. Cosine squared is going to be equivalent to 1 minus sine squared x. We still have a plus 2 sine x minus 2 equals 0. How can I clean this up?
Well, the first thing we could do is like add the 2 over. Or add the 1 and the 2 together and then add that over to the other side. Or are we trying to keep them on the same side?
I'm going to keep it equal to 0, but I do want to clean up my like terms is what I would call these. So I'm not going to add the 2 over. I'm just going to say, because they're already on the same side, I'm going to say what is 1 minus 2? negative 1. So negative sine squared x plus 2 sine x minus 1. I'm not a big fan of that negative out front.
So then
Multiply everything by negative 1, which basically, and we can do that because it's an equation. Changes all the signs, right? Sine squared x minus 2 sine x plus 1 equals 0.
or no, you can
We can't factor out. Okay. Here's your visual in orange. If we drop off the signs, just ignore the signs for a brief moment. This is what it correlates back to algebra 1 level. Sine squared x minus 2x plus 1 equals 0. Or algebra 2 level if you don't want to go that far back. Okay. How do we solve this? X squared breaks into x and x. What multiplies to be 1 and adds to be negative 2. Negative 1 and negative 1. Except these aren't really supposed to be x's, are they?
No, they're sine.
So if I go back to my actual problem, instead of saying x minus 1, it's sine x minus 1 times sine x minus 1 equals 0. Which could also be written as sine x minus 1 quantity squared, but doesn't matter. Okay, what's my next step? Solving step.
You said both parts equal to 0, since you're the same part, you have to do ones, right?
Okay, yeah. Officially, it's, two things multiplied equals 0, set them each equal to 0. Now, in this case, I'm going to say sine x minus 1 equals 0, or sine x minus 1 equals 0. So yes, we are solving the same thing twice. So we don't have to, we can just solve it once. So then, how do I solve sine x minus 1 equals 0? Add the 1 over. Sine x equals 1. What was the other, somebody, Jacob, did you say? Uh-huh. Sine x equals 1. I think we already answered this question, didn't we? When does sine equal 1? Pi over 2. Except you're not going to tell me pi over 2 this time. We're going to use 90. And I will say, see example 4. If you're going to look back at this later and say, how the heck did we come up with 90? We used example 4 to help us, right? We did that last year in pre-cal. You didn't like it then either. My hope is it made a little more sense today.
Yeah.
It's not horrible. I mean, if you're strong in your algebra, this is just a pre-cal version of algebra. It's not horrible. Or a trig version, but. Okay. So, 2 sine squared x equals 3 plus 3 cosine x.
So, just an idea. Since it's like 3 plus 3 cosine, could we just, like, the 3's, like, not ignore them for now, but, so could it be like, instead of equaling sine squared x minus 1, would it be 3 sine squared x minus 3, or no?
I did not follow.
So, the 3 cosine x.
Mm-hmm.
Okay, but not, since it's not squared, it doesn't equal it.
That's what, okay. You were trying to change the wrong thing, weren't you? Okay. Yeah, we're going to have to make this one all cosines because the sine squared is what we can change. So we're going to have to go the direction of that. So you guys want to make that first step then? Okay, so sine squared x is going to be replaced with 1 minus cosine squared x. Dang it. So that's that right there, isn't it? Still equals plus 3 cosine x. What are you doing on the next step? Eventually, yep. I was thinking distribute. Okay, that's fine. Keep working. I'll catch up with you. Distribute, make it equal 0. Get me a positive squared value. Finally, come on. There we go. So I did not distribute. I'm going to say 2 minus 2 cosine. Which way did you move things? Or does it matter? Okay, so if we move the 2 and the minus 2 cosine squared x over to the other side, because I know I want to end up with a positive cosine squared x, kind of technically makes it 0 equals positive 2 cosine squared x, still plus 3 cosine x, and then plus 1. Can we see that okay? Do you need a side visual again? Two x squared plus 3x plus 1 equals 0. What are options for this?
Well, I was going to say, we could do like product of AC, because since A is 2 and C is 1, you do like what adds to 3 or multiplies with 3.
Okay. So we can do product of AC. Have we reviewed product of AC this year?
I don't think so. I mean some of the homework.
Do we remember product of AC? Because here's what I'm going to say. I am not a product of AC person on my own. I teach it and that's what I use in class because that's what you guys do best with. Because this is a 2 and this is a 1, this is really easy for me to just put automatically in parentheses because I only have so many choices here. And so, even at calc level, you guys may not like me for this. But what's the only way we would ever divide up 2x squared? Yeah, so 2x and 1x, right? If you look over here at 1, what's the only way you divide up 1? 1 and 1. These right here are both positives, right? So what are these signs going to be down here? Both positives. There's not any extra options. Product of AC is really helpful when you have lots of options to run through and try. But now, do you believe me that this worked? Maybe not. I mean, here, foil it, right? Do a quick mental foil. 2x squared times x is, or 2x times x is 2x squared, right? Outsides, 2x. Insides, 1x. 2x and 1x is 3x. And then last, 1 times 1 is 1. Did it work? Yeah. Now, we can review product of AC at some point if we need to as well. But to me, that one was too easy to waste my time with product of AC, is my personal opinion. Okay, so what this really is, though, these aren't x's. This is 2 cosine x plus 1 equals 0. Whoops. I should really be writing that not as equals 0 quite yet, because I should write out in factored form just for making the notes. 2 cosine x plus 1 and cosine x plus 1 equals 0. There we go. Now if I set each part equal to 0, right? 2 cosine x plus 1 equals 0. Cosine x plus 1 equals 0. What do you know about 2 cosine x plus 1 equals 0? Yep, subtract 1, divide by 2, negative a half. Cosine x plus 1 equals 0. Cosine x equals negative 1. Find some answers. What angle is our reference angle here? When does cosine equal 1/2? Okay. 60, or what I'm going to say as pi over 3, because we need to talk in radians in this problem. Now, is pi over 3 one of my answers? No. Because we need to think all students take calculus, and we need negatives. So we need which quadrants? 2 and 3. We need to know what it is in this quadrant and what it is in this quadrant. So that means we're going to go up pi over 3 and down pi over 3. And that means you're going up and down pi over 3 from pi, which is the even better angle of 3 pi over 3. 2 pi over 3 and 4 pi over 3. When does cosine equal -1? Go back up to example 4 where I already have the chart. I don't know if you guys drew it in your notes, but you already have it drawn up there, don't you? So cosine equals -1 at pi. Any place else? Nope. Okay. It's a big old trig review. That's big old chapter 5 stuff from last year.
I don't know, I feel like I have it.
I mean, the truth always happens when you have to work it on your own, right?